Okay, this is section 4.8, Functions and Relations. So the first thing I want to do is I want to go over some definitions. A relation is any set of ordered pairs. Now a function is a special relation. A function means that for every input, there is only one output. And most of the time in the things that we talk about, for each x value, there's only one y value. So we normally talk about it in terms of x and y. But the input for us is generally our x value. Sometimes it is called the domain. And the domain is along the horizontal axis. Now the output value is also called the range. And that falls along the vertical axis. So we normally think of the input value as our x values and the output value as our y value. Okay, now we're going to look at these and we're going to decide if these guys are functions. So on the first set, my input values are 1, 2, 3, and 4. My output values are 2, 4, and 5. So this is just another way for them to write actually a set of ordered pairs. So this is the same thing as saying I've got the point 1, 2, I have the point 2, 4, I have the point 3, 4, and I have the point 4, 5. So that's just another way to list an ordered pair. Now it's a function if for each input value there's only one output. So I'm going to look. 1 only goes to 2. 2 only goes to 4. 3 only goes to 4. 4 only goes to 5. So when I look at this, I know that this is a function. Now sometimes if it is a function on your homework, they're going to say if it is a function, list the domain. Well, the domain is the x value. So the domain would be 1, 2, 3, 4. They also want you to list the range. The range would be the output values. So in this case, it would be 2, 4, and 5. Now, if a range value occurred more than one time, you would still only list it one time. Let's look at the next one. My input values are 1, 2, 3, 4 again. My output value is 5, 7, 9. Oh, but look right here at this one. 1 goes to 5 and 1 goes to 7. So for my input 1, it has two outputs. So this would not a function. And I'm writing FN to represent function. Now another thing I can do is I can actually look at my graph and just look at it and determine if it's a function. So what I'm going to do is I'm going to use something called the vertical line test. So I'm going to look and I am going to see if there's any spot that if I were to draw a vertical line that it would cross through this graph 2 times in 2 places at the same time. So when I look, there's no place that I can draw a line, a vertical line, where it's going to cross this graph 2 times. So this one is a function. Let's look at this one. This one's got a funny shape to it. So if I were to take a vertical line all the way through, there's no place that it's going to cross this line or this graph more than one time. So this is also a function. Now let's look at the last one. Now this one's a little bit different. If I draw a vertical line, oh, look what happens. It crosses my graph in 2 places. And because it crosses my graph in 2 places with that one vertical line, I know that it is not a function. So if it only crosses one time, it's a function. If it crosses more than one time, it is not. Okay, now function notation is f parentheses x. And it's read as the value of f at x. So whatever the x value is that we want to plug in. It does not mean f multiplied by x. You have to be really careful with that. F of x is just a really fancy way to say y. And you may also see it written as g of x is pretty common, h of x is pretty common. But all these are just different ways to say x. I'm sorry, to say y. Okay, now the reason this is so important is because it's going to give us an opportunity to easily label our information. So our directions for this one say to evaluate the function for the given value of the variable. So I have f of x is equal to 2 times x minus 3, where x is equal to negative 2. So I'm going to use function notation, and function notation tells me I've got the function evaluated at negative 2, and all that means is wherever I have an x, I'm plugging in negative 2. So f at negative 2 is equal to 2 times negative 2 minus 3. So f at negative 2 is equal to 2 times negative 2 is equal to negative 4. Bring down my minus 3. So f at negative 2 is equal to negative 7. This actually gives me an ordered pair. My x value is negative 2. My y value is negative 7. So now I have the point negative 2, negative 7. So this is going to help me label my information. So there's going to come a time when we're doing a lot of different problems, evaluating one function with a lot of different values, and this is going to allow us to label our work so we know what work is located where. Okay, let's do this one. Evaluate the function for the given variable. This time I've got g of x. It's still just a fancy way to say y, and I'm evaluating it when x is equal to 0. So I have the g of 0 is equal to negative 5 times 0. Oh, this one's easy. Negative 5 times 0 is 0. Oh, guess what? When x is 0, y is 0, that's going to give me the point 0, 0, or the origin. Now don't get too caught up in this. G of x, it's a fancy way to say y. My x value is 0. What I get over here is my y value. G evaluated at 0. It's just a label. Just remember it's a label. One more. F of x is equal to 7 minus 3x when x is equal to 4. So now I have the function evaluated at 4 is equal to 7 minus 3, plug in 4 for x, times 4. F of 4 is equal to 7 minus 12. F of 4 is equal to negative 5. Signs are different. Subtract the small number from the large number. Keep the sign of the large. So this gives me the ordered pair 4, negative 5. So things are working exactly the same. It just looks slightly different. Okay, now graph the function. Now I have f of x is equal to 2x minus 3, and they want me to graph the function. It's the exact same thing because remember, f of x is just a fancy way to say y. So I'm going to do it. Oh, look, it's in y equals mx plus b form. It's in slope-intercept form for me already. So what's my slope? Oh, my slope is equal to 2. Well, whenever I have a number that's not a fraction, I'm just going to throw that guy over 1 because that's going to help me remember what my rise is and what my run is. And what's my y-intercept? That's right, it's -3. So the first thing I'm going to do is I'm going to plot -3. 1, 2, 3. So now my y-intercept is plotted. Now I need to do my slope. It's a positive slope. I'm going to rise 2, 1, 2, run 1. There is my next point. Connect. I'm done. It graphs exactly the same way. The only thing different is that it says f of x instead of y, but they mean the same thing. Okay, now we're going to take a moment and we're going to find the slope. Okay, now remember from earlier, they've given me my ordered pairs. I've got the formula for slope. I know that slope is equal to y sub 2 minus y sub 1 over x sub 2 minus x sub 1. They've given me my ordered pairs. They look a little bit different. If it helps you to rewrite it, look, this is my x value. F evaluated at -3 gives me -9. So my input was -3. My output is -9. Over here, my input is +3. My output is +9. I'm going to label my points so I can plug those guys into the formula. X sub 1, y sub 1, x sub 2, y sub 2. I'm going to plug it into my formula. My slope is equal to 9 minus -9 over 3 minus -3. Well, 9 minus -9, two wrongs don't make a right, but two negatives make a positive. That turns into 9 plus 9, which gives me 18. 3 minus -3 turns into 3 plus 3, which gives me 6. Simplify my fraction. 18 over 6 reduces down to 3. So the slope of this line is +3. And that's all there is to it. So go ahead and complete the homework that's posted on Moodle. If you have any problems, send me an email and I'll see you guys on Tuesday.